7.5 is over rhombi and squares. So rhombus is the singular, and our squares that are there. Helps if I'm using my pen correctly. There we go. Okay, so a rhombus is a parallelogram. So again, parallelogram properties apply with all four sides congruent. Okay, all the properties of parallelogram hold true in addition to the following two theorems. So in a rhombus, if a parallelogram is a rhombus, then its diagonals are perpendicular to each other. So when you draw the diagonals in here, they form 90-degree angles with each other. They're kind of an interesting thing. And then if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So another thing that happens here is that instead of just being congruent to each other, they actually bisect the opposite angles. So these angles are congruent to each other, and these ones are congruent, and then we've got congruence here and congruence here. Now, the reason that I drew the opposite sets, so all four of those congruent, is because we know opposite angles are congruent, and we know that the diagonals bisected the angle. So if this angle started out as like 120 degrees, this one's 120. When it's bisected, 60-60. Well, when that one's bisected, same thing, 60-60. Okay, so that's kind of the idea behind those. But we have those two kind of new theorems in play for that. A square is a parallelogram with all four sides and all four angles congruent. So it's a parallelogram, all of those properties apply, but notice the properties of a parallelogram, of a rectangle, and of rhombi apply to squares. So the diagonals of a square bisect each other from a parallelogram, they're congruent from a rectangle, and they're perpendicular from a rhombus. That's an example of kind of how you combine everything. So there's lots of things that are true within a square, okay? Okay, so we have to be careful about what is given to us, what information we have for each of these, because now that we've learned about parallelograms, rectangles, and now we're on rhombi and squares, we've just got to be really careful because there's different things that we know. So quadrilateral is a rhombus. So they're telling us it's a rhombus. What I know then is I know that we have these congruences. I know that my diagonals bisect each other. If I'm just looking at this stuff, my diagonals are not congruent, okay, but they do bisect those opposite angles. So I would also have something like this. I mean, there's so many things to draw in that you just can't draw them all in. But you also, one of the other big ones is that you know that we have 90-degree angles in here. Okay, so 90-degree angles in that. So lots that I just drew in there. Let's see what comes up. So AZ is equal to 14. So AZ, this piece here is 14. So I'm also going to mark this one as 14. ZY, let's see where that is. ZY down here is 22. So that's all of the sides are going to be 22 then, because the rhombus, all the sides are congruent. Angle WYZ, I'm going to pick a different color. WYZ. So this angle down here is 35. And so then I know this one's 35, and then I could also come over here and do 35s. So let's just fill that in. Let's see if that's enough. So it asks us for XZ. So XZ would be from X to A and A to Z. We have 14 and 14. So add those together, you're going to get 28. Angle XYZ, so XYZ together, so you're going to put those two together, you're going to get 70. And WXZ, this angle here, I had a feeling they were going to ask for that. So if we look at this triangle in here, we have the 35-degree angle that's up here. We have the 90-degree angle here, and they're asking us for that angle. Well, we know all three of those angles add up to 180, so we can do 180 minus the 90 to get 90, minus the 35 then is going to give us 55, and that's what that angle is there. So that's a 55 degree angle. Again, just making sure I didn't copy anything wrong. Nope, we're good. Okay. So then we have another rhombus given to us in this one. And so I'm at the bottom of page 438. It gives us, so I'm going to not draw in my properties. I'll do those in a little bit. So PQ is equal to 4x plus 3. So we have that. QR is equal to 41. So right now I'm gluing myself into those two things. And PQT, this angle in here is 2x plus 4y. We got another variable in there. Okay, so what must be the value of y for the rhombus to be a square? So we want this to be a square in this case. So first thing I'm going to do is solve for x. So I know that 4x plus 3 is equal to 41 just because this is a rhombus. So we subtract 3, I get 4x equal to 38. I divide by 4, and I'm going to get x equal to, let's do some math here. 9 times 4 is 36, and 9 1/2. So that's going to be my x value in this case. And I'm going to use that now in order to help me solve this. So there's one angle. If I want this to be a square, I want that whole angle to be 90. And with a rhombus, they bisect, or the diagonals bisect the angles, so these are congruent. So actually, I want 2x plus 4y to be equal to 45 degrees. Okay, I know the x is 9.5. And so then I'm going to solve from there. So if I solve this out, I should get y to come out to 6.5. Okay, that's how I'm doing that one. Again, pause the video and go through it if you need to, and check what you're doing there. Okay, so tests for rhombi and squares. How can we prove that something is a rhombus or a square? And the answer is yes, okay? If the diagonals of a parallelogram, so if you know you have a parallelogram and you can prove the diagonals are perpendicular, okay, then you can say that it's a rhombus, okay? If one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram's a rhombus, okay? You only have to have one diagonal, but they have to bisect a pair of opposite angles. This one doesn't get used a ton, but it is there, okay? If two consecutive sides of a parallelogram are congruent, okay, think about that. You have a parallelogram and you have two consecutive sides that are congruent to each other, then you're going to have a rhombus. Or if a quadrilateral is both a rectangle and a rhombus, then it's a square. So we've already talked about how to prove that we have a rectangle. Now we've talked about how to prove we have a rhombus. And when we can do that together, we can get to a square. So let's go over this real quick before I end this video. Is at this point, if we want to prove that we have a rectangle, okay, starting with if we have a parallelogram, okay, then we should be able to prove that we have 4 right angles, which really only requires us to prove that we have 1 right angle, because we did talk about that earlier. Is that if we have 1 right angle, then we have 4 right angles, okay? We can prove the diagonals are congruent to each other. If the diagonals of a parallelogram are congruent to each other, you have a rectangle. If you want to prove that you have a rhombus, then you're going to start with a parallelogram and you are going to prove that you have 2 consecutive sides congruent. That's a big one that comes up. You're going to prove that your diagonals are perpendicular. Okay, you could have all 4 sides congruent, but you really only have to, once you have a parallelogram, prove 2 consecutive sides congruent. Okay, so those are the big ones. And so therefore, to prove that you have a square, there's lots of things you can do, but if you have a parallelogram, you can prove that the diagonals are congruent and perpendicular. Okay, or a lot of times what comes into play here is just like, what are we doing? Well, a lot of people don't want to do a distance formula, just how you get your diagonals congruent to each other. So if you want to just do slopes, you're going to prove your diagonals are perpendicular and you're going to prove that you have 1 right angle, so that 2 of the consecutive sides are perpendicular. And that's how you can get there. Now, there's lots more ways to prove that you have a square because you just have to combine 2 of these. Okay, so that's the idea there. Okay, I'll leave it there for now.